Hey guys, so for our last section in chapter 1, we're going to be talking about a different type of voting system called weighted voting. This is a different voting system than what we looked at because in the past we've been awarding one vote per person, but in this weighted voting system, some members of a voting power or a voting body have more votes than others, and so that's what it means to have a weighted vote. Now, you might be asking yourself when this actually happens, why it's fair to grant people more votes than others. And a lot of times, the reason that this happens is because we're picking a representative for a certain body of individuals. And then we have like a council meeting where we're selecting that person to vote on the other people's behalf. So if I was, say, voting, like you can kind of consider like the Electoral College kind of like this, where we're voting, Maine gets however many votes based on its population, and it's supposed to be representing Maine. So they get more votes than, say, Rhode Island, because Rhode Island's smaller than Maine, or Texas gets more votes than Maine because Texas is bigger, and so more people live there, so their votes that they have should end up being more proportional to their body. So that's this idea. It's not giving one vote, but it's giving maybe more than one vote to others. And in that system, we create what's called a coalition, and this coalition just really means a collection of votes. Now, if I'm winning some weighted voting system, this is only happening by a majority. That's how we win a weighted voting system. If we don't have enough votes to pass an issue, those that do have enough votes to pass an issue in that set is called a winning coalition. So we'll see what that looks like in a second. Now, this collection of votes that we're looking at, I can't really see that pen very well, I'm going to switch. In that section, or this idea of this coalition, is that we're going to be looking at this different collection of what voting could happen. And that'll help us decide what's called this voting power, which is our second section that we're kind of talking about. So we're going to look at this situation and see what it looks like if we do end up being this or using this idea of a weighted vote. So in this first part, we're going to consider a high school, which we have 3 class levels. I don't know where all the freshmen are. They're gone. So we're only going to look at sophomores, juniors, and seniors. Maybe freshmen don't count. I don't know. The sophomores have a significantly higher class than the others. So they have 500 people. The junior and senior class only have 300 people. And we pick one member to represent each of the classes. So it wouldn't make sense to only give them each one vote because sophomores are more people, so it makes sense to give them more votes. So maybe what might make sense is to look at this proportionally. So this is a 5-to-3 ratio, 5-to-3-to-3. So let's award sophomores 5 votes, and juniors 3 votes, and seniors 3 votes. So we can all agree probably that that makes sense and that seems fair. Like if sophomores have 5 votes and juniors have 3 votes and seniors have 3 votes, all these votes are proportional to the amount of people that are in their class. So this makes sense. This is something that would be quote unquote fair. So we're going to look at the coalitions, which we're going to look at all the different collections of votes that could happen. And we're voting on like an issue. So let's say we're voting on like, I don't know, homecoming court or something like that. And the sophomores and the juniors and the seniors are all going to vote on this particular person. So it's going to be like a yes or a no vote. This means that when we look at this coalition, we're going to look for all the possibilities that we could have. So one possibility is that all 3 of these bodies, all 3 of these people, all 5, 3, and 3 vote no on this person. So that would mean that since everyone votes no, 0 votes are cast to say yes to someone on homecoming court or whatever the issue may be. So to actually represent this coalition notationally, we look at a set. So set are important with these curly brackets. Do the best you can. If you can't create a curly bracket, I'm okay if you just do a squiggly line like this. That's okay. But it does need to be a set in this set notation because that's how we're representing these coalition. And it talks about we'll talk about this a little bit later, but set notation's specifically saying that this order doesn't actually matter. So that's why it's in the set notation. So we list all the voters that voted say yes and the number of votes that totals to. So on this first issue, all these people could vote no. So that would mean that nobody voted for our group, which would mean that we end up having no votes. So again, this represents no people voted and we have 0 votes totaling this issue. One option is that only sophomores voted. So I'm going to symbolize sophomore as SO and juniors as JR and seniors as SR. So one possibility is that sophomores vote yes and junior and senior vote no. So that would be 5 votes total. Another possibility is that juniors vote yes and everyone else votes no. So that would be 3 votes total. Another possibility is that seniors vote yes, no one else votes yes. So that would be 3 votes in total. So yeah, those are possibilities, and I like to go in order like, okay, no one voted yes, one person voted yes, so that would be these 3 different combinations. We could also have the combinations of sophomores and juniors both voting yes. So 2 people voting yes, so sophomores and juniors. If sophomores and juniors both vote yes, that would be 5 votes and 3 votes, so 8 votes in total. If sophomores vote yes and seniors vote yes, that's another combination that we could have. That would be 8 votes in total. And another combination is that sophomores vote no, juniors and seniors vote yes, so junior and senior, which would be a total of 6. And there's no other combination to pick 2. That was kind of all we had. That's why it's in set notation, because it doesn't matter if I say yes and yes versus yes and yes. The order in which you list these doesn't matter. It's important that both of them are in there. And the last option that we have is that if all 3 voted yes. So that would be sophomores, juniors, and seniors alike, which would mean we'd have 5, 3, and 3, so that's 11 votes that would vote yes. Okay, so remember we said that if we're voting yes and we're trying to pass some issue or, elect a homecoming recorder, wherever we're doing, we can only do this, it's the only win if a majority has selected this. If there's not a majority, then that issue fails and it does not get passed. So if we have 11 votes in total, the number of votes that we need for a majority is 6. So 11 divided by 2 is 5.5. We can't have 5.5 votes. So that means that we have to have actually 6 votes in order to pass this issue. The winning coalitions are the ones that would actually have 6 votes. So in this whole list, all of these are losing coalitions. So if seniors are the only ones who vote yes, then it would not pass the issue. So that's a losing coalition. But if juniors and sophomores voted yes, they got 8 votes, which means the issue would pass. The person would be elected or whatever it is. So these 4 things that we have in our list, all the ones on this side, are the only ones that would pass the issue. They're the only winning coalitions that we have. This one is actually kind of unique. If we look at this situation versus any of these situations, this one is unique because removing any representation, removing just, not any necessarily, but removing representation. Oh yeah, any, just kidding. Would still pass. Meaning, like, all 3 of these people voted yes on the issue, and it definitely passed the issue, whatever it was. But if I got rid of sophomores from this list, and juniors and seniors are the only ones who voted yes, we already have that combination over here, and it still passes. So this one's unique because if I remove some of these pieces, the issue still passes. This is what's called a minimal winning, or I guess the opposite of what a minimal winning coalition is. A minimal coalition is a coalition in which all voters are necessary or essential to pass. So in this one, it's not a minimal winning coalition because sophomores actually aren't essential in this combination. Juniors actually aren't essential in those combinations. I didn't need juniors to win. To vote yes. I just needed sophomores and juniors. So these all are minimal winning coalitions because I needed sophomores to get to eight votes. I needed juniors to get to 8 votes. Sophomores alone could not pass the issue, so I needed someone else, and so both people are necessary to pass this. This is not minimal. It's still a winning coalition, but it's not a minimal winning coalition. So if I analyze these pieces that are necessary to pass or essential to pass, sophomores are involved in 2 of these voting systems. Juniors are involved in also 2 of these voting systems. Seniors are involved in also 2 of these voting systems. So that means that sophomores are essential for 2, juniors are essential for 2, seniors are essential for 2, meaning, or what that really means is that all combinations of how these things might work, everyone is essential for the same amount of possibilities. This idea of essential for means power. So the voter only has enough power when it belongs to a coalition that needs its vote. This is something that everyone ends up being essential for the same number of coalitions. So what that really means is that all these people have the same power. That's what this number really represents. This is their power in the situation. Now, this actually represents a paradox, and the reason is that all these people have the same power, but all these votes actually aren't the same. So even though sophomores have more votes, they end up having the same amount of power. As the juniors and seniors. So interestingly enough, that this weighted voting system that we have does not often and always reflect the population distribution. This is something that we thought at the beginning seemed really fair to give them 5, 3, and 3 votes, but it actually didn't reflect how that distribution was distributed. It didn't actually matter that we gave sophomores 5 votes instead of 3 votes. That was actually irrelevant. If we were going to have something that was reflective of the population distribution, we would have to give sophomores even more votes and look at this power distribution that we have. So in order to do this idea, we often use an algorithm called the power algorithm that does just that. It takes this number of votes and it analyzes this number of coalitions, and it actually determines what actually is the population distribution, or what that voting system actually does reflect as far as the population distribution is concerned. And if we do want something to be distributed with the population, we have to have votes that reflect that. So how this works, this power index algorithm, is kind of what we just did. So we just listed all those coalitions that were possible, and specifically the ones that mattered were the winning coalitions. And then within those winning coalitions, we looked at these voters and we decided if these voters were important for that coalition. So we're going to start with a base level of 0. And in that voter system, like whether we pick sophomores or juniors or seniors, we're going to record them as a 0. But then we select these coalitions and we figure out if we remove that coalition, that's what it means by subtract the number of votes, if that number is less than the number of votes required to pass an issue, then we give that voter 1 point. This really means, is answering the question, are they essential? If they're essential, we give them a point. And we keep doing that until the end of the goal. So in other words, instead of doing like these set rules, we can kind of skip all those and really answer this question or ask this question every time that we're looking at them. Give everyone a point if they are essential for that coalition to win. That's what it boils down to. Are they essential? If they're essential for that coalition to win, give them a point. A voter that has all of the power. So let's say you do this and it actually means that they have all the power and everyone else has zero, has a power of zero. This person's called a dictator. So they don't need, person B and person C. In fact, it's irrelevant what they vote for. It only matters if person A votes yes or no, and that's the only way it could pass. That would be a dictatorship. If a person has no power or a power score of zero, they're called a dummy. Poor dummies. In other words, they're like a dummy hand. Like whatever they vote doesn't actually matter. It doesn't impact anything. They are irrelevant in the decision-making process. So they're kind of on the sideline. So let's do another example. We looked at the sophomores and juniors and seniors example, and we analyzed that a little bit more. We're going to do that with just like these 3 random voters, K, J, and E, and we're going to say that these voters have 5, 3, and 4 votes respectively. So again, we have to list out all the possible coalitions, and then we're going to identify these coalitions. We're actually going to circle the winning coalitions so we can see those a little bit better. Listing out all the possible coalitions is really similar to the one we just did. So we have the option of either every one of these people voting yes or no. So if K votes no and J votes no and E votes no, that means that no one voted yes on the issue. That means that we have 0 votes in order, saying yes or trying to pass this issue. K could vote yes and everyone else votes no, so that would be only K, which would be 5 votes. We could have only J vote, which would be 3 votes. We could have only E vote, which would be 4 votes. And then we have the combination of 2 of them voting yes and 1 of them voting no. So that could be K and J, which would be 5 and 3, which is 8 in total. We could have K and E, which is 5 and 4, which is 9 in total. Or we could have J and E, which would be 7 in total. And that's all the combinations that we have for those 2 people. And then our last one is that they all voted yes. So we end up having 8 different possibilities. So that would be 8 and 12 votes in total. So we have 12 votes. We have to now decide what our winning coalitions are. So we have to determine how many votes we actually need to pass an issue. If we have 12 votes, that means that we need not 6, but 7 votes to pass an issue. Majority means that more than 50%, 6 would just be 50%, so we need a majority rules. We need 7 votes to pass in this case. So looking at our options, I have these 4 that have 7 votes. Everything else has less than 7. So now we have to determine our power index, so K, J, and E. Again, what this means is that we look at each of these coalitions and we give them a point if they're essential to pass it. So if I remove K from this list, does it still pass? Does this still have 7 votes is really the question I'm asking. And for this one, if I remove K, then this vote number goes down to 3 and it fails. So K is essential for this one. So I'm going to give K a point. And I keep going. So this next one, is K essential? If I remove K, I'm down to 4 votes. Then it fails. So K is essential. So far it's essential for 2. It's not part of this coalition, so I can skip it. This last one, if I remove K, this vote number goes down to 7. It still passes. So it's non-essential for that last one, which means I stop at these 2. So it has a power index of 2. So I do the same thing for J. J has 3 votes. If I remove it from this first coalition, I'm down to 5. 5 does not pass the issue, so J is important. It is essential for that one, so I give it a point. It's not involved in this one. This next coalition, J again has 3 votes. If I remove that, it goes down to 4. 4 fails that issue, so J is important. It is essential to pass that issue. And this last one, if I remove J from the list, it goes down to 8. 8 still passes, so it's non-essential for this last one. That means I stop with my power index of 2. Same thing for E, it's not part of that one. If I remove E, this goes down to 5. That means that E is essential because that would fail without E. Same thing here, if I remove E, it goes down to 3. 3 would fail the issue, so E is important. And here, if I remove E, it goes down to 8. 8 is still something that would pass it, so it's not essential for that last one. So this is really similar to the last example that we have. This would be the power index for all of these. They actually have equal power despite having these differences in votes at the start. So this is another paradox where K seemingly has more power because it has more votes, but K actually has the same amount of power as everyone else. All right, so the last example. We're still going to list all these possible coalitions. We're still going to identify the winning. We have the same possibilities as above, but the number of votes actually change. So I'm just going to start kind of copying down, but then changing how many total votes would actually have. So it's possible that no one votes. It's possible that only K votes, which would be 5. It's possible that only J votes, which would be 1. It's possible that only E votes, which would be 1. And then again, it's possible that 2 people vote and not the third, so that would be like K and J. If K and J both vote yes, that would be 6. It could be K and E, which would also be 6. It could be J and E, which would be 2. And then the last combination is if everyone votes yes, which would be 7. So we have 7 votes in this case. So in order to come up with the winning coalitions and circle those, we need to figure out what the majority would be. 7 divided by 2 is 3.5. I can't have obviously 3.5 votes. I need more than that. So the next one would be 4. So I need 4 votes to pass. So I look at all the different combinations that have at least 4 votes. So that gives those 4, slightly different array than our last one. And so when we're determining our power indexes, remember what that means is that we look at all the coalitions that K is involved in or J is involved in and E is involved in, and we decide how many they're essential to pass, how many they're necessary. So in this first one, obviously K is important because if we remove K, we go down to 0 and it fails. So K is important in that case. Our next one, if we remove K, we go down to 1 vote, and that would fail, so K is important. It's essential. Same thing here. If we remove K, it goes down to 1 vote, so it fails, so K is essential. In this last one, if we remove K, this would go down to 2 votes. 2 votes fails, so K is actually important in that last one. It's essential to pass that issue. So we're up to 4 for K. J is not involved in that one. J is here, so J has 1 vote. If we remove J from the list, we're down to 5 votes. That still passes, so J is non-essential for this one. J is not involved. J is involved here. If we remove J from this list, it goes down to 6. So again, J is non-essential. So that means that J actually is sad and has a power index of 0. If we do that same thing for E, not existent, non-existent here. If we remove E, it has 1 vote. That goes down to 5. 5 still passes, so it's non-essential. Same thing here. If we remove E, we go down to 6. 6 still passes, so E is non-essential for that last coalition, which means E is joining J and has a very, very small power of 0. In other words, J and E have no power. It does not matter if they vote yes or no. It will not help to pass an issue. It will not help lose an issue. So these two are dummies. And since they're those are the only 2 people involved and they're dummies, or K is the only one that's involved besides them, K actually has all the power, so K is a dictator in this example. And you can kind of see that actually if you look at the differences here, if you look at the votes, since I need 4 votes to pass the issue and K already has 4 votes by itself, and these people combined, like since 1 and 1 don't even combine to pass an issue, then K definitely will end up having all the power in that situation. There's no way that without K they can't pass it, or without K it's impossible to pass an issue. So K has all of the power. It's a dictator. Okay, I have slight change to make to the bottom of this so that you can look at that later. This you're only going to have to do number 8, not 8 through 11.